Okay, here we go. We're going to dive into factoring. So if I would get the factors of something, that would be what it can divide by. Okay, so like if we're doing normal factoring, like 12's factors, like if you do a factor tree, it could be 2 and 6, and then 6 breaks down to 2 and 3. We don't have to do all that, but as you can see, 2 and 6 and 3 are factors of 12, other than, of course, 12 and 1. We're doing so we're going to have to put on our dividing caps. We got to think about these in terms of what can I divide both of these numbers by, in this case, for the first one. So I have 12 and 18. And when I factor, I ask myself what they both can divide by. In this case, they both divide by 6. You could say, oh, they both divide by 2, yes. And then you'd be left with a 6 and a 9. And then the 6 and the 9 still can be divided each by 3. So you can do that. You can just keep breaking it down and take out more than one number in different steps, but it's easier just to do it all in one step when you think of the biggest number. So this divides by 6, and this divides by 6. So I'm going to take out a 6, and then, so I divide it by 6 now. So 12 divided by 6 is 2k, and then you always keep whatever sign was there, and then you divide this one by 6. 18 divided by 6 is 3. So this is, the expression factored would be this. If you're ever not sure and you're like, and I do this all the time, okay, even me, as yes, I'm, pretty good with math, but I always will double check myself and go, okay, does 6 times 2 equal 12? Yes, so I'm good. Does 6 times 3 equal 18? Yes. So if I go backwards and check my multiplication to get those, then it's a little bit easier because we, at least for me, I can quickly identify those multiplication facts a little bit quicker than the division facts. So that's what I do. So these would be your two factors. And then if you do it the breakdown way where you're like, oh, I take out a 2 and then I'm left with 6k minus 9. Then you do it another way and take out the 3. Then you would have to leave the 2 and take the 3 out. And then take the 3 out of 6, which is 2k minus 3, and then just simplify this to 6. Okay, so that is practice with greatest common factor. So let's take a look at another one. Okay, we have something with more variables, but that's okay. We're going to work it out. So we've got these two terms. We've got this term, and then we've got this term, right? So what will divide by the 40 and 64? I'm thinking maybe 8. Yeah, because I'd be left with 5 and 8. So we want to divide both of these by 8. This could be another way you could think about it. All right, next, we do have to take out something else, right? What you're doing is you're seeing what they have in common. Common factors. So common factors, and they don't have to be just your numbers. They're your variables as well. So look at your x's. And then what you want to pick out is your lowest set of x's that they have in common. So they do have x to the 8th, and they have x to the 4th. So this is the same as 8 x's. So x times x times x, 8 times. And then this would be 4 times. So how many do they have in common? They would have 4 in common. Yeah, because this one has 4, and this one has more than 4. So you always take out your lowest number. So we would take out x to the 4th. And then, just for kicks and giggles, I'm going to do these in different colors, just in case it helps. Alright, I've got a y. How many y's do I have? 1. And then how many y's do I have here? 1. So, yeah, they both have a y, so I can take out a 1y. Alright, now I'm going to finish this, and put what's left. So, when you're factoring, you're taking out, it's like a coefficient, like backwards distributive property, okay? So we want this to ultimately look like the distributive property where we have a number out front and then we multiply it by this one and this one. So that's all it is factoring is getting to a place where you could distribute back. And you might be like, what's important with this? We'll get there. It's important. I know it's kind of tedious, but it's important. Alright, so 40 divided by 8. So we take each term and divide by what we took out. So 40 divided by 8 would be left with a 5. And then 64 divided by 8, took out an 8, and we're left with an 8. Alright, I know I've got some x's left. So here, okay, first term, I have 8 originally, but I took out 4. So how many do I have left? I have 4 left. And then the y's. I took out the only one that they both had, so we're good. And then this one, the x's, I took all 4 out, can't do anything, I took out the y. As long as, see how this matches this? That means they were all factored out, so I don't have any more x's or y's over here in this term. Okay. Alright, and then, of course, to check your answer, you mentally take this and say, alright, 8 times 5 is 40, 8 times 8 is 64. This times this is really, you add the exponents. When you multiply common terms, you add their exponents to get you 8, and then the y, and then etc. Okay, so that would be your results for number 2. Okay, all right. Then I'm going to let you try that one. This one, I just want to point out, when you have 2 variables, this can be kind of tricky. You do have to keep them together and ask yourself, all right, how many of each do they all have in common? So let me kind of get you started on this one. So they have the A, right? Let's look at the A's real quick. So they got an A, an A, and an A, and this one actually has 2 A's. So pick out your lowest number of A's, which would be 1. Yeah, so we take out 1 A. And then how many B's do they have each? So this one has 2, this one has 1, and this one has 1. So the lowest number is 1B. Okay, so you would still do it like that, just then when you fill in the result, you just take out 1. These are really 1s. You can treat them as 1s and write them as 1s if you want. So you take out 1, take out 1, take out 1, and etc., and then leave how many are left over. For example, this first term you took out an A, so there's no more A's. B, you took out one of the B's, so you still have a B. Let me put it in the right color. So you still have a B left in this term. And then I'll just go ahead and insert these. So it was a negative, and then a positive, and then that. So that's how it'll look like. Usually you'll still have your 3 terms. So leave room for your how many terms you had to start with, and then just insert the signs, minus and plus. Alright, since those are kind of beginning practice, I want you to try these and pause the video. Okay, press play when you are ready to see the results. Alright, let's see how you did. So, on number 3, you could take out a 7 from each of these, and an m squared, leaving you with 2m to the 4th minus 5m minus 1. I've seen a lot of mistakes in the past with this part right here. People want to put 0, but that is not going to work. Because what happens when you multiply 7m squared by 0? Let's say you were checking your answers and trying to get the original. Anything times 0, or if you have nothing there, is nothing. So you cannot result in this value if you don't have your 3rd term. So we have to, and this is always going to happen, okay? If you take out exactly what was there, 7m squared and 7m squared, that means you've divided by 7m squared. You've divided by everything. And if you've divided by everything, then that simplifies to what? Anything over itself is really 1. So that's the biggest mistake that I see when factoring. Well, one of the big mistakes when factoring, I should say, is that people just eliminate this all together and say, oh, it's gone, it's disappeared, so it's 0. No, it's still a 1, because this times negative 1 would just insert your negative out front, making this still happen. Okay, so that's important. Number 4, taking a look at this one. So 3, 5, and 8 didn't have anything in common, so we couldn't take out any numbers. This 1, I went ahead and put it here, is optional. You don't have to have it there. It's fine if you don't have it. And in this next one, so 3b was left, minus 5a, and then plus 8. Okay? Alright, So let's continue on filling this in. When we are factoring, we are always looking for a GCF, which is, of course, greatest common factor. If you forgot what that means, you should write that out. Greatest common factor, which is up here too. All right. Write that out if you need to. All right. So we're going to start with this. Now we're going to practice factoring trinomials. So trinomial is a 3-term. Okay, 1, 2, 3. We got 3 items. So these are all trinomials, or they look like this. They're quadratic in standard form. Ax squared plus bx plus c, where a is 1. So we're doing these where a is 1. That's really the only way you can do it. Now, there are multiple ways that people have been taught these. I'm going to show you my way, and then we'll see about another way after that. So I do a T-chart. This is what I do. Okay? And I take my 2 terms, B and C, and so these are the numbers I'm worried about. So 14 is going to go here. So this is my B term. From right here is what I'm looking at. I don't want to confuse you with my colors, so let me delete that. And then I'm concerned about this number right here, and this is my C. And you put this number here, okay? So in my T-chart, I have my C value here and my B value here. Also, don't forget the signs, okay? In this particular case, they're both positive, so I don't have to worry about a negative. But if they were, I would carry a negative over here with that. All right. This is your, and just to kind of get you started on it, this column is your multiplication column. Sorry. I don't know what that was. Multiplication column. And then the other column is your sum column, okay? So what we're trying to do is come up with 2 numbers that multiply to get this value, 45, and add to get this value, 14, okay? So we're thinking of factors that multiply to get 45. So what 2 numbers can you multiply and get 45? What times what? In other words, what times what equals 45? 1 times 45, and this is positive, so we're just looking for positive values. What else? 5 times 9. All right, and well, since we have 9, we know that 3 is a factor. So 45 divided by 3 is 15, so it could be 3 times 15. So that's a way to check and see, do I have any more factors? Do any of these divide by anything else? 15 divides by 5 and 3, but they're already there. So those are really all we can list right now. So if I do 1 times 45, I get 45. 5 times 9 will give me 45. 3 times 15 will give me 45. So those are all the possibilities. These are just possibilities. And then I'm going to eliminate them based on what happens with the sum. I'm looking for a sum of 14. So a sum is, of course, adding. Okay, so 1 plus 45 would equal 46, right? And that's not going to work. That's not 14, so we know it's not that one. What about 5 and 9? 5 plus 9 is 14. Ding, ding, ding. You really can just stop there and say, oh, that's my answer. Just to verify what I'm doing, we'll add these, and you get 18. So if this number was 18, you'd pick this set. If this value was 46, you would pick this set, okay? But we, of course, got this set. So that means we care about these 2 factors. So now these are your factors because we got a matching result of 14, okay? So all we care now about is our 5 and our 9. All right. What that means is you can write your factors like this, and it's positive and positive, because we got a positive 45, is that we just take our variable, which was x, put that in the first spot, and then since they were positive, we put plus, and then we insert those values, 5 and 9. And then that would be the factored form of the original trinomial, x plus 5 and x plus 9. Just to verify this, okay? And because you can kind of check this in the graphing calculator. So we're not using the calculator to factor. It's not really, we can't do that at this moment. But we can check our factoring in the calculator. So let's type in the original, x squared plus 14, x plus 45, which I think I already put in there, yeah. Alright, and then we, of course, are looking for the solutions, because that's where factoring is going to help us, is with the solutions. Let's look at the solutions on this. So right here, I have a solution of -9 and -5. -9 and -5. In terms of factoring, what did I get? +9 and +5. So it's the opposite. And that's the tricky part of checking your answer in the calculator, is that they're the opposite signs. So check, we can note this, check in calculator, and they're opposite signs of the zeros, or x-intercepts, or roots, whatever you want to call them. I'll just put zeros. So these should be the opposite signs, and they are. They're positive instead of negative. Okay? Alright. And then the next step that would come after this is if you're solving, and we're gonna do this in another second, you know, in the future. So just to remind you, because you probably saw this in Algebra 1, is that we say, okay, this equals 0, so what is x? To make this value 0, it would be -5, and then the value of x in this one, what value of x would make this term a 0? -9. So all you do is take the opposite, or get x by itself, and then the results are -5 and -9. So they are the solutions, but as far as the factoring, they have the opposite signs. Okay, so just keep a note of that. Mental note. Mental note. All right. Let's go ahead and do another one. Okay, I wanted to show you the other method you may have been taught, and there have been multiple ways that I've heard over the years that teachers now teach factoring. But one that came up one time was the box method, so let me show you that. And I'm not 100% familiar with it, but this is what I kind of know. So you will take your value here and put it here, so x squared, and so you create this box with four boxes. This goes here, your last value goes here, so 45. Alright, and this is whenever you have a x squared. So then you will automatically put an x and an x here, because what this is the numbers on the outside you multiply to get the number in the inside. So x times x is x squared, and then you have to figure out the rest of it based on this number, the 45, and then these two numbers have to add up. So to get 45, you would kind of do the same idea. You would test your factors and say, all right, it could be x 1 in 45. So therefore, 1 times 45 would equal this 45. But then we have to fill this in and see if this works out. 1 times x is x, and x times 45 is 45x. And then it would write out, and then if these two add up to my 14, then we're good. But they don't. 45 plus 1 would equal the 46. So it's the same idea, it just looks a little bit different. And then I'll show you that how to get the answer. So then after that, you would test 5 and 9. And say, all right, x could be 5. Oh, I was trying to write 4. X could be 5 and 9, so you test this set out, and you get 5 times 9 to equal that. Then you would multiply 5 times x and get 5x. And multiply 9 times x and get 9x. And then you just have to check and make sure that these add up to get your 14, which they do. So resulting in your answers are on the outside of your boxes. So your answers for factors are right here and here. And since they were positive, we do need those plus signs. So giving you x plus 5 and x plus 9. Okay? So that's the best way that I can explain that. So if you learn factoring a different way, stick with that way, that method. Okay? If you have any questions about different ways of factoring, ask me and I will do my best to help you use whatever way works for you. Okay? But I like this. I like the 2-column aspect. It's just a little bit simpler, and you know, that's just what I learned. So a lot of times we stick with what we know, and that's okay. Pick whatever way works for you. All right. So let's go ahead and do another one just to kind of get ourselves situated and helping out with another one. So this is my last term, 26, and this is my middle term. In this case, it's negative. So I do need to keep that negative with the 15. 26 was positive. I don't have to put that there. But last term first, and then the middle term last. Okay? It's consistent with what we did over there. So let's write out factors. 1 times 26, 2 times 13. Did any other factors come out of that? I don't believe so. Nope. Nope, we're good. So this is all we got. So these are our multiplications. So we're good with this column. Now we're just seeing what we sum. So we add them to get this value. So 1 plus 26 is 27, and 2 plus 13 is 15. Okay, now, hey, what's the best option? Looks like it's going to be this one, because we're close, right? The only thing we're not getting is a negative. How can we get that negative? So I'm going to go ahead and eliminate this pair. All we would have to do is to make both of these negative, right? Yeah, that's all we got to do is so insert a little negative here and a negative here, because the nice thing is a negative times a negative is still a positive, right? Negative times a negative is still a positive 26, so we're allowed to use 2 negatives. So adding these, negative 2 plus negative 13 will give me negative 15. So that's all I had to do was plop in 2 negatives, and then I get my negative 15. Okay? Alright, so now that I have my factors, I just set it up, always set up with 2 parentheses. It's going to become a binomial and another binomial. And then you just insert your numbers. Over here we inserted positive 5, positive 9. Here we're going to insert negative 2 and negative 13. Okay? And that is how you factor. So not too bad. I know the first one was kind of long. It's kind of long at first, but it's not too bad once you get used to it. So I need you guys to seriously practice these. Okay. So I am going to pause the video, and I want you to just do 5 through 10. So do the next 4, 7, 8, 9, and 10. Okay. Try these on your own. Okay. Don't skip this part and just write down the answers. You really got to try these. Alright, pause the video. Press play when you're ready. Alright, here we go. Coming at you with some answers. So, number 7 came out to C plus 8 and C minus 6. Let me go ahead and talk about this one since it came out to have a negative product. So when it's negative, you still write out your factors, and then what you're really going to see this time is a difference in the numbers. So I'm looking for a pair that has a difference of 2, because that's always going to be, if I'm getting a negative product, it's always a positive times a negative, or a negative times a positive, same idea, and we're going to actually subtract them. So this set right here, I quickly eliminate that in my head because they don't have a difference of 2. And then same thing here. I want a small difference. So if this is a difference because of this being negative, I want 2 numbers that are close to each other of 2. And that would have to be the 6 and the 8. 6 and the 8 are close to each other, separated by 2. The next question is, so which one is negative? Okay, it could be the 6 that's negative or the 8 that's negative. And it depends on your adding. So now you try it with both. Say, okay, 8 could be negative, so do negative 8 plus 6. Or 6 could be negative to get this 48. 2 ways. This one could be negative or this one could be negative. So do a negative 6 plus 8. Which one is going to give me a positive 2? Notice again, I'm doing the symbol, the sign is positive. Now, it does matter. If this was a negative, I'd be in a different scenario, but it does matter which value has the negative. So which value gives you a positive 2? That would be this one right here. So you would stick with that one, and then so you'd have a positive 8 and a negative 6, giving you your factors. Okay. Then number 8 resulted in a negative and a negative, and same idea in that one. You want to look for two numbers that are close to each other. Since that's a small number, yeah, 8 and 9 are close. It would have to be a negative 9 and a positive 8. Number 9 shouldn't have been too bad. Both positives. So 6 times 6 is 36, 6 plus 6 is 12, giving you a plus 6 and a plus 6. You can also rewrite this as, or you will see it written as a plus 6 squared, okay, because it's just a term times itself, so we can just write it as one term with an exponent, okay. Alright, number 10, similar type thing happens. I have a positive 1 and a negative 2. If you have that, you know both your numbers are going to be negative to get that. So a negative, because a negative times a negative is a positive, and you add them and get negative 2. So both of your factors are negative 1 and negative 1, resulting in this. Alright. So 11 and 12, you have an additional step you have to do. You have to, you can only factor when the coefficient of your trinomial is a 1. In this case, what they've done is given you something that's not a 1. It doesn't start with a 1, it starts with a 2. But easy peasy lemon squeezy, you see that my other coefficients also divide by 2. So I'm going to go ahead and just take that out first to start out. So I take out this 2. I'm left with k squared. So this is what the common factor, greatest common factor. Always take out your GCFs. These other ones didn't have GCFs. These ones do. So dividing by 2, 16 divided by 2 is 8. 40 divided by 2 is 20. So it's the same problem. I'm just making it look smaller. I'm taking out my factors, making these numbers as small as possible. Now I have this trinomial. And what you have to do is recognize, alright, I've got my coefficient of 1, and I can do the same thing I did up here. I just don't have to worry about the 2 now, and I'm just going to get this part. Alright? So putting in your last number, negative 40, and putting in your middle number, negative 16. Let's see, 5 and 8, 4 and 10. Is it one of those? I think it is one of those. Yes. Oh, wait. I messed up. Miss Hensley, what did you do? Yep. I put in the wrong numbers. I was looking at the wrong one. Let's fix this. Alright. Sorry, you don't want to look off this one anymore. Oh, that was my big mistake. Now I'm looking off of this one. Whoops. Alright, negative 20 and negative 8. 4 and 5. 2 and 10. Anything else? I think that's it. Yeah. Alright, so I'm getting a negative, so that means one of these is going to be negative. If I'm doing a product and getting a negative, one of them has to be negative. So is it 4 and 5? So I'm looking for a difference of 8. Okay? Remember again, when this is negative, I'm looking for a difference instead of a sum. It's just a little trick. So which one of these has a difference of 8? Yeah, that one. So I'm going to eliminate that and say, all right, 2 and 10 have a difference of negative 8. Now, which one is negative? I don't know. Let's test both. Negative 2 plus 10 or 2 plus negative 10? It would be this one. Since I get a negative 8. 2 plus negative 10 is negative 8. So those are my two factors, positive 2, so k plus 2, and then minus 10, k minus 10. Alright, now we're all factored nice and neat. Okay, why don't you go ahead and pause the video and try number 12. Alright, so checking number 12. Take out a 5, you're left with z squared minus 5z plus 6. So 6 is your product, negative 5 is your sum. Being that this is a negative, we know that we're both going to have negative numbers, but to start out, I'm going to go ahead and put 2 and 3. Negative 2 plus negative 3 would result in the negative 5. This one would not. Negative 1 plus negative 6 results in a negative 7. So we pick the minus 2 and the minus 3 for our results, giving us z minus 2 and z minus 3. So this was our result factors for number 12. Again, remember you can check these also in Desmos. So if I type in the original, y equals all of that. And also keep in mind you can't put z in there. It usually gives you an error. So change your z's to x's. And you get your factors right here where they cross the x-axis. But they're the opposite signs. Okay, so it's really minus 2 and minus 3 for our factors. Yes, the zeros, the solutions are positive 2 and positive 3. Those are the solutions. But we're talking about factors. Factors are one step before the solution. So it's x minus 2 and x minus 3 to give me these results of positive numbers. So keep that in mind. Alright, the negative 2, negative 3, just when you graph it, you get the positive version, or the opposite sign. Okay? So don't forget, you can check your factors that way in the calculator. Okay, now we have another type of quadratic factoring that we're going to do. So we still have a quadratic, but the difference is now our first coefficient of x squared, or a, is greater than 1. And it's also usually prime. In fact, those are really the only ones we're going to worry about, is when a is greater than 1 and usually prime. Okay, prime meaning it has no other factors other than 1 in itself. For example, this one has a factor of 2, and 2 doesn't have, it doesn't have any other factors other than 1 and 2. This one has 5. Okay, its only factors are 1 and 5. You don't have any other factors of 5. So to do this one, you're kind of gonna, I do this trial and error way. It's the easiest way for me to do it is, I say, okay, I have 2x squared. I know my x's are going to be split up. That's what the factoring does, is it splits this up into a binomial from a trinomial. So I know I'm going to have an x here and an x here. That's always going to be the case. Same thing on this one. I know I'm going to have a p here and a p here because I've got 2 of them. That's always going to be the case when you're doing quadratics. I'm dividing up, I'm splitting up this first term into separate x's. Then I just carry this to one of them. I just go ahead and put it with the first one. Because I know to get this, I'm going to have to do 2x times x squared, and that's a 1, so my 2 doesn't change. Same thing here with this 5. Alright, then the next thing I care about is, let's pick that one, is really just the last number. It's easier if you start with the last number. So in this case, I got positive 18. So I'm trying to get positive 18. And then I'm going to go ahead and do terms, factors kind of like before. Am I going to do a 2 and a 9? Or am I going to do a 3 and a 6? We'll find out here in a second. Or I could do a 1 times an 18. And I think that would be all the possibilities that I could try. So I'm trying to get positive 18. So now I'm just going to plug and chug and see what happens. Okay, and one thing to note, if it's positive, but I have a negative, that means my two numbers are both going to be negative, because a negative times a negative is a positive. So I know I'm going to have a minus and a minus, because a negative number times a negative number will give me 18. You see what I mean in a minute. So I'm going to try the 2 and the 9. Is that going to work? So negative 2 times negative 9 is a positive 18. I know that. Now I'm trying to do the sum and still get negative 15. So is this, now I'm going to have to factor this out in my head now. I don't have to worry about the first two terms, but now I'm going to do this one times this one, which is negative 18. So 2x times negative 9 is negative 18. And then I have to do the next one, which is minus 2x. So is that going to work? No, that doesn't give me the negative 15. So I'm working this backwards, which takes definitely some practice. So it's not 2 and 9. Let me just make sure I'm looking at the right thing. Yeah, so it's not 2 and 9. Alright, now I'm going to try, and you also, actually, you are supposed to try the backwards. I just remembered about that. 9 and 2. So you multiply the first and the last to give you negative 4, and you multiply this one and then the two middle ones, negative 9. And that would give me a negative 13, and yes, which doesn't work. So you are supposed to switch them around. I forgot about that. Alright, let's try the 3 and the 6. So again, they're going to be negative, negative 3, and negative 6. So multiply the first and the last, and that would give me 2 times negative 6 is negative 12, and then this would give me a negative 3, which is negative, and I'm doing the last step like I did over here. I'm adding them. I have to do a little bit more work because they're not the same coefficients. So yes, this time I do get the negative 15. So this is the correct answer. Just to show you what happens if I switch them, it's actually the wrong answer. Because I would get 2 times negative 3, which is negative 6, and then negative 6 times negative 6, or times 1 is negative 6, they're giving me negative 12, so negative 12 is not what I wanted negative 15. So it does matter the order that the factors are in. Oops, I didn't have to do that. So this case does work. Okay, so you may be wondering, well, how could I check this in the calculator? Let's type the original into the calculator. 2x squared minus 15x plus 18. And your two zeros in this particular problem are these. So keep in mind, even though I'm in the positive side, they're really negatives. Minus 6 and minus 1.5. Let's see what that looks like compared to our solutions. Minus 6 and minus 1.5. So I got one of them. The reason you get one of them is because it's got the coefficient of x x has a coefficient of 1. So this factor, what would make this 0, is a positive 6. So that's why the positive 6 shows up. Now why does this show up? 1.5. What would make this a 0? So all you have to do is say, well, really, if I take all this and equal 0, 2x minus 3 equals 0, I got to add 3 to the other side. 2x is equal to 3, and then I divide by 2. And so x is equal to 3 over 2, which is the same thing as 1.5. So it's really my 0, okay? Or you can just say it's going to be this number divided by this number. Negative 3 divided by 2. So negative 3 divided by 2 would be just change to positive on your graph, okay? So that is how you would check and compare the solutions on your graph to the factors that you get and how they're related to each other. So remember, you can always FOIL this back in, and just another way to check your answer is to do this, and this is kind of what you're doing when you do this process. 2x times x is 2x squared. 2x times 6 is negative 12x. Negative 3 times x is negative 3x. So these will combine and give you that negative 15. And then your very last terms, negative 3 times negative 6, give you positive 18, which does result in this term. So you just FOIL it all back out to make sure you get the original. That's how you check your answer. Alright, I know that's a long way. There may be another way to do this, and I'm not as familiar with this way, but again, hey, we're all going to learn, and even if I got to learn, that's okay. We're going to try one more way of doing this. So what you will do is, and you may have already gotten to this point, I wrote this out earlier. If you already did that problem, that's fine. Just go ahead and check with what I'm about to do. Alright, so what I'm going to do is multiply this times this. And then I'm going to go ahead and keep it as a coefficient of 1 for both of them. So 5 times 48 is 240. So I'm moving it over here, and then I'm going to keep it in this spot. You put the result here, and it's a negative, since a positive times a negative is a negative. 240. And then, oh, I messed this up already. It's alright, we'll get it. We'll get there. I'm writing this as a trinomial with a coefficient of 1. I got ahead of myself. Alright, so that's going to stay as p squared. And then you're going to keep the middle. So I'm just getting rid of this coefficient, so I have a coefficient of 1. And so multiplying that, and then there's 2 more steps we have to do. Now we're going to do this step. Alright, now you kind of do what we did before. So we have 240, negative 240, sorry, and a positive 22. And then you start coming up with products that are going to give you the negative 240, but have a difference. Since I have a negative, I'm looking for a difference of 22. And just kind of go ahead and jump ahead and tell you it's going to be 30 times 8. 30 times 8, you carry that 0, and 3 times 8 is 24. And that's how I know that's going to work out. Now I got to figure out which one is going to be negative. So is it going to be negative 30 plus 8, or is it going to be 30 plus negative 8? And again, this is, you're going to test both because that's a negative. And which one is going to give me the positive 22? Which one gives you the positive 22? This one or this one? Definitely that one. So these are going to be my factors. So I'm going to add the 30, and then I'm going to minus an 8. Now that's not it. Remember, I multiplied that 5 in there. So the 5 is going to come back. It's going to come back to haunt you. That's what this method, the trick in this method is this last step. Okay, this last step, you got to remember to bring that 5 back. What you do is divide both of these by 5. Since you multiplied it by 5, now we got to divide it back out. Divide both by 5, and then the 5 is going to go with one of them. Recording. Okay, there we go. So we're dividing both by 5. How do I know and where the 5 goes? It's going to go with the one that would give me the decimal. Okay. So just to finish this out, you would have p plus, this divides and gives you 6. And then p here, oh, I'm getting ahead of myself again. Getting so excited. Then your 5 goes in front of the p, in this case, because I'm getting a decimal. So that means your 5 is going to go in front of this case because I have a decimal. This case, no decimal. And then I'm going to minus, and you're just going to keep the 8 there. You're not going to change it. This is the result of your factoring, okay? So it is a little bit, I'd say, less confusing than this other method, as far as entirely method, but there's just a lot of steps that you got to remember to do it this way, okay? So you can FOIL this back out and see that you get the original. Also, don't forget, you're testing this. If you test this in the calculator on your graph, you will get this one should go through negative 6. This one should go through negative 8. 5/5. Negative 8 over 5, whatever that decimal is. Okay? So, I'm just going to give you one of these to practice. So go ahead and just practice doing number 15. Only number 15. Okay? Pause the video and then press play when you're ready. Alright, so I went ahead and did it the last way. I went ahead and multiplied 3 times negative 40 and got the negative 120. Your factors just end up being bigger numbers when you do it this way. So resulting in negative 24 and positive 5 being your factors to give you the negative 19. So I'm now at this step. I just kind of went ahead and stopped here so I can remind you what to do. So now that you have your two factors, we got to take our coefficient that we got rid of and divide everything by the coefficient. If we get a whole number, great. H minus, this would be an 8. And then this one's going to be my decimal. So instead of making that a decimal, I'm going to go ahead and put that in front of my h, giving it 3h plus 5. Okay, so that was the result of that one. I'm not worried about these other ones because they have coefficients that are not prime, and I don't want to do too much of this quite yet. We'll just practice that for now. And one other thing I do want to mention is difference of squares. We are going to be doing difference of squares, and we're going to learn some more. So all you do for difference of squares is if both numbers, or both terms, oh, that's not an E. I don't know what that it's just a pretty cute. Really cute. If both terms can be square rooted or have a perfect square root. Okay, in this case, x squared can be square rooted and you have x in x. And then this can also be square rooted because that's what squares are. They mean perfect squares when they say this. And that's 2 and 2. And then all you do to get this minus is you have different signs in order to get that. So that'd be negative and plus. And then test it out just to show you that it works. Foil it back. X times x is x squared. X times 2 is 2x. Negative 2x times x is minus 2x. And then the last two terms, negative 2 times positive 2 gives you your negative 4. And what happens with your two middle terms is they cancel out. So all we care about is the last term, or first and last, and then in the last one to get our. So the red is your factors of difference of squares. So we've got the same concept in the rest of these. And I don't want to worry about one like that. Let's just keep it simple. Not worried about one like that. In fact, I'm not really worried about one like that yet either. Why don't you just go ahead and do 22 and see if you can get the right answer. Pause the video and then press play. Alright, hopefully that was not too bad. Square root of y is just y, or y squared is y. Square root of 81 is 9. So y minus 9 and y plus 9 would be your two factors. Okay? Alright, so that's it for the factoring refresher. So we'll get started on a couple more things with factoring. Factoring just takes more time, so yeah, the videos are going to be a little longer because of that, but you do have to know it. So, see you next time.